Far below the surface of the Pacific Ocean, where the last trace of sunlight dies 1,000 meters above your head, something pale is swimming in water so deep it has no name most people can say out loud. It moves slowly, like a ghost that has forgotten it is dead, drifting through black water under a weight that would crush a submarine if that submarine went deep enough and stayed there long enough. This creature was filmed 8,336 meters down, in the Izu-Ogasawara Trench, south of Japan. And that single piece of footage made history because no fish had ever been seen alive that deep before in the entire history of human exploration. Scientists did not just break a record that day. They broke an assumption that had quietly sat at the bottom of marine biology for years, the assumption that below a certain depth, a fish with a backbone simply could not survive. Picture the weight of that water for a moment. At the surface, the air presses on you with about 15 pounds of force on every square inch of your body. And you never notice it because your body pushes back with the same force. Now go down 8,336 meters, and that gentle pressure becomes something else entirely, more than 800 times stronger, like having the entire weight of a small mountain standing on your chest forever. A human being dropped into that darkness would be dead before they finished falling, their lungs crushed, their rib cage shattered, their bones ground down by a force the human body was never built to meet. And yet, in that same water, barely large enough to cover the palm of your hand, a tiny fish was swimming, feeding, and acting as if the crushing weight of an entire ocean was nothing more than a light breeze on a summer day. That fish should not exist. That is not drama, that is not exaggeration, and that is not a narrator trying to make a story sound bigger than it is. By every rule of physics and every calculation in the chemistry of life, a fish-ette, that depth sits right at the absolute edge of what a backbone can take. And the scientists who filmed it spent their whole careers arguing that almost nobody believed anything lived down there at all. By the end of this story, you will understand why that little pale fish changes everything we thought we knew about the deep ocean, why it was found in a place scientists said was too far, and why the team that filmed it came home knowing they had seen something that, on paper, should have been impossible. And you will understand why, even now, the question of what lives just a little deeper stays open. The stage for this discovery is a crack in the Earth's crust so deep it makes the tallest mountain on the planet look small. Mount Everest rises just under 9,000 meters above sea level, and if you could somehow pick it up and drop it into the Izu-Ogasawara Trench, its summit would still be almost a kilometer short of reaching the surface. That trench slices through the Pacific Ocean south of Japan, a long dark scar in the seafloor where one plate of the Earth's crust dives beneath another, and at its deepest point the bottom waits, nearly 10,000 meters down. Most of that trench has never been seen by human eyes. It is too deep for submarines built for the shallows, too far for cameras lowered by rope, and too dark and too cold and too silent for anything that needs sunlight to survive. Scientists call this region the hadal zone, and the name is not an accident. Hades, in the old stories, was the underworld, the place beneath the earth where nothing living was supposed to go, and the researchers who named this layer of the ocean reached for the darkest word they had. The hadal zone begins, roughly 6,000 meters down, at the point where even the abyssal plains give way to something stranger, and it only exists inside the deep trenches that score the ocean floor like knife wounds. Together, those trenches cover less than 2% of the ocean bottom, but they hold roughly half of all the depth in the entire world ocean. A folded, hidden landscape of cliffs and walls and dead-end basins where the rules of ordinary life stop applying one by one. In August of 2022, a research vessel called the DSSV Pressure Drop sailed into those waters, carrying a team that had spent years chasing the deepest fish on Earth. The Pressure Drop is not a glamorous ship. It is a converted offshore supply vessel, the kind of workhorse boat that spends its life hauling equipment for oil rigs, rugged and functional and built for rough seas rather than for fame. But its name comes from something real, because the people on board were there to hunt the pressure itself, to go where the water weighs more than anything on the surface ever will, and to find out once and for all whether fish really lived at the deepest edge of the habitable ocean. Leading that expedition was a scientist named Alan Jamieson, a man from the University of Western Australia, who had made the deepest fish on Earth his life's obsession. Jamieson had spent more than a decade lowering baited cameras into the darkest places on the planet, watching hours of footage of nothing, waiting for the moment when something alive drifted into the light of his lander. He had already found fish deeper than anyone had before in the Mariana Trench, the deepest trench in the world, and he had built a reputation as the man who went looking for life where other scientists said there was nothing to find. On that ship with him were researchers from the Tokyo University of Marine Science and Technology, Japanese scientists who knew these waters like their own backyard, and together they had a plan that seemed almost too simple. They would drop camera systems straight down into the Izu-Ogasawara Trench, deeper than any fish had ever been filmed, and they would wait to see what came to eat the bait. What they found would rewrite the record books, and it is worth staying with this story because the reveal at the bottom changes the way we see the entire ocean. If you think you already know how this ends, if you assume the deep sea is empty and dead and boring, then the next few minutes will show you that assumption was wrong in a way that still makes scientists shake their heads. The team was not expecting a miracle. They were following a scientific hunch, a careful chain of logic that said the deepest fish in the world might be hiding in exactly this trench, and the evidence they needed was sitting more than 8,000 meters below their feet, waiting in water that has been dark since before the first dinosaur walked the earth. The tools they used are called landers, and they are deceptively simple machines. A lander is basically a frame of metal, a camera, a set of lights, and a trap, all weighted down so it sinks straight to the bottom, and it carries no engine and no pilot and no way to steer. The team baited these landers with mackerel strapped on the cameras and then simply let go, watching the machines sink into the blue, then into the black, then past the point where any human being could ever follow. Each drop was a long gamble. The lander falls for hours, sometimes most of a day, and all the team can do on the surface is watch the depth numbers climb and hope the equipment survives the pressure that would crush a car like a soda can. Imagine standing on the deck of that ship, watching the water turn from bright to dark as the lander disappears, and knowing that somewhere below you, in the freezing black, a camera is falling toward the bottom of the world. The descent takes so long that the crew eats meals, works, sleeps, and wakes up to find the lander still falling. There's no way to rush it. The pressure down there is so immense that the lander must be built like a fortress, its electronics sealed inside glass spheres that can shrug off the crushing weight of 8,000 meters of ocean. And even then, every drop is a roll of the dice. Sometimes the camera fails. Sometimes the trap triggers too early. Sometimes the whole machine comes back empty, having sat for days in the most hostile environment on Earth, with nothing alive ever coming near. To understand why scientists doubted anything lived down there, you have to understand what that water does to a body. Pressure at 8,000 meters is not just uncomfortable, it is a force that changes the very shape of matter, and any animal with air inside it would be destroyed in an instant. The deepest fish have no swim bladder, the gas-filled sac that keeps ordinary fish buoyant, because a swim bladder at that depth would collapse into a crumpled bag. They cannot have air pockets anywhere, cannot have rigid bones that would splinter under the strain, and even the shape of their cells must be built to survive a squeeze that would crush a human skull like an eggshell. Everything about being alive at that depth is a workaround, a long list of impossible problems that life somehow solved. The cold is part of the problem, too. At 8,000 meters, the water hovers just above freezing, a degree or two above zero, and the darkness is total in a way most people never truly experience. There is no moon, no sun, no glow, just black. Water that has not seen light for millions of years. And the silence is so complete that the only sound is the faint thrum of your own blood. Food is almost non-existent, a slow drizzle of dead plankton and fish waste that falls from the surface like snow. And biologists used to argue that no fish could survive on that starvation diet in that crushing cold at that impossible pressure. That argument made sense. It was logical. And it was completely wrong about how stubborn life can be. The search for the deepest fish has a long history of breaking its own records, and each new record pushed the limit a little further into the dark. For decades, the deepest fish anyone had seen were found around 7,000 meters, and scientists began to talk about a barrier, a point beyond which fish could not go. Then, in the Mariana Trench, the deepest hole in the ocean, researchers found the Mariana snailfish, a pale, translucent creature built out of jelly and determination, and it pushed the known limit of fish life past 8,000 meters for the first time. The Mariana snailfish held the record for a while, caught and filmed in water nearly 8,000 meters deep, and plenty of researchers assumed that was about as far as a fish could possibly go. The reason they assumed that comes down to chemistry, and specifically to a molecule called TMAO, a name that sounds like alphabet soup, but actually holds the secret to deep sea survival. Under extreme pressure, the proteins inside every living cell start to fold up and stop working, like a machine whose parts have been squeezed out of shape. And deep sea animals fight this by packing their cells full of TMAO, a chemical that protects proteins the way antifreeze protects an engine. The problem is that the deeper you go, the more TMAO you need. And the calculations said that somewhere around 8,400 meters, a fish would need so much TMAO that the chemical itself would start to poison it. That number was the wall. That was the reason the deepest fish seemed to have a hard limit, a ceiling set, not by pressure or cold, but by the chemistry of life itself. But Jamieson had a hunch that the wall might be higher in some places than others because not all trenches are the same. The Mariana Trench is cold and isolated, a desert of a seafloor. where food is scarce and the water is some of the oldest in the ocean. The trenches off Japan are different. They sit in richer waters, fed by currents that carry nutrients and food down from the surface, and they are warmer than the Mariana at the same depth, which means the chemistry of survival works a little differently there. If the limit was really set by TMAO and temperature, Jamieson reasoned, then a fish in a warmer, richer trench might be able to survive just a little deeper than a fish in a cold, starving one. That single idea that the wall might move is what sent the pressure drop sailing toward the Izu-Ogasawara Trench. The Izu-Ogasawara Trench was the perfect test case because its bottom sits at a depth where the theory said fish might still have a chance. The team's landers were built to reach nearly 10,000 meters, deep enough to touch the very bottom of the trench, and the plan was to work downward in steps, dropping cameras at deeper and deeper sites to map exactly where fish life gave out. If the theory was right, they would find fish a little deeper than anyone had before, maybe around 8,000 meters, and that would be a triumph on its own. If the theory was wrong, if the wall was real and immovable, they would come home with footage of empty water and a stubborn, respected null result. Either way, the science would advance, but nobody on that ship was expecting the footage they actually got. Each drop followed the same patient ritual. The lander goes over the side, the depth counter starts climbing, and for hours the crew watches numbers tick past 5,000, 6,000, 7,000 meters, each thousand a frontier that fish had only recently conquered. And on nearly every drop, something surprising happened. Almost immediately, because the deep sea is not as empty as the old textbooks claimed. Within hours, the mackerel bait began to draw scavengers out of the darkness, swarms of tiny, shrimp-like creatures called amphipods, pale and almost transparent, boiling over the bait in numbers that stunned the team. The amphipods were proof that life was out there, waiting in the black, and where there are amphipods, there is often something bigger hunting them. Day after day, the pattern repeated. The lander sinks, the bait sits on the bottom, the amphipods arrive, and sometimes, in the deeper drops, the camera caught the ripple of something larger moving at the edge of the light, a shape that was gone before the lens could focus. The team cataloged hundreds of hours of footage, most of it showing nothing but the slow drift of marine snow and the frantic feeding of amphipods. And that is the real work of deep-sea science, patience, repetition, and very long stretches of apparent nothing. But every empty frame was building toward something, because the team was methodically climbing down a ladder of depth, and the ladder had a rung that no fish had ever been known to reach, and they just did not know yet which rung that would be. If you are feeling what the crew felt out there, the mix of hope and doubt and the strange pull of the deep, then this is the moment to hit like and subscribe, because the footage that came out of this trench is the kind of discovery that only happens once in a generation. These are the stories about the ocean that keep coming back to you, the ones that change how you see the water every time you look at it, and there is more waiting at the bottom of this one. The team kept dropping their landers deeper and deeper, past the depths where any fish had ever been seen, past the point where the old records ended, and the water below them was about to give up a secret it had been keeping for millions of years. The moment came on a drop to 8,022 meters, a depth so far down that the numbers alone hardly make sense to the human mind. The lander reached the bottom, the trap closed on schedule, and the crew hauled the machine back up through the miles of water, a pull that takes hours and always carries the quiet worry that the prize has slipped away. When they opened the trap on deck, they found two fish, small and pale and completely unremarkable to anyone who did not understand where they had just come from. They were juvenile snailfish, barely 11 centimeters long, and they had just become the first fish ever caught alive. Below 8,000 meters in the entire history of science. The record for the deepest fish ever captured had been broken, not by a few meters, but by a long, clean fall into the unknown. The fish on that deck did not look like history makers. They were soft-bodied and almost translucent, their flesh so gelatinous that they seemed closer to jellyfish than to the familiar fish in a market. And they had no scales, no armor, no visible defense against anything. That is the secret of their survival, because at that depth hardness is a weakness and softness is a strength, a body. Made of water and jelly, simply yields to the pressure instead of fighting it. The team handled them with the care that record-breaking research subjects deserve, photographed them, measured them, and preserved them for the scientists back home. And every person on that ship understood that a theory had just fallen. The wall that was supposed to stop fish below 8,000 meters had a hole in it. But the catch was only half the story because the landers carried cameras as well as traps, and the footage from an even deeper drop held something that made the catch look almost ordinary. On one of the deepest deployments of the expedition, at 8,336 meters, the camera captured a fish swimming past the bait, and the crew on the surface watching the feed could hardly believe the depth reading glowing on the screen. This was not a fish that had drifted down by accident. It moved with purpose, swimming steadily, investigating the bait, comfortable and unhurried in water that would kill anything carrying air inside its body. It was a snailfish, a relative of the two fish caught above, and it was swimming deeper than any fish had ever been filmed in the history of the planet. Think about what that footage actually shows. A pale, ghost-like fish, not much longer than your hand, gliding through black water under a weight that would flatten steel, at a temperature just above freezing, in a place where no light has ever reached. It approaches the bait the way a fish in a garden pond approaches a breadcrumb, and it seems to have no idea that it is doing something impossible. The image is grainy, lit only by the lander's own lights, with particles of marine snow floating through the beam like slow-falling snowflakes, and it is one of the most important pieces of ocean footage ever recorded. Because that fish was not struggling, not lost, not dying, it was home. The numbers deserve to be said slowly because they are easy to miss in the rush of a story. 8,336 meters is more than 27,000 feet, which means that fish was living deeper than any fish had ever been documented, deeper than the previous filmed record by several hundred meters, in a place that sits below the cruising altitude of a commercial jet turned upside down. The expedition confirmed the find in April of 2023, when the species was identified as a new snailfish in the genus Pseudoliparis, and the Guinness World Records Organization later certified the footage as the deepest fish ever captured on film. A tiny fish had taken the record that had belonged to the Mariana Trench and moved it into a Japanese trench, and every map of deep sea life had to be redrawn by a few hundred crucial meters. What made the discovery even stranger was that the fish in the footage was not a tough old survivor hardened by a lifetime in the deep. It was a juvenile, a youngster, barely big enough to be out in the world at all, and that detail is the one that really unsettled the scientists. A young fish at 8,336 meters means the fish are not just passing through that depth. It means they are breeding there, laying eggs, hatching, and raising their young in water that should be a killing zone, and an entire population of snailfish is living out its full life cycle in the deepest layer of the ocean, where fish have ever been found. The juvenile was not a stray, it was the child of a thriving community, and that changes the story from a single lucky sighting to proof of a whole hidden world. Think about what it means that a breeding population lives at that depth. It means the snailfish found a way to solve every single problem the deep ocean throws at life. The pressure, the cold, the darkness, the starvation, and it solved them so completely that it reproduces there generation after generation. The eggs hatch in near freezing water under crushing pressure. The larvae drift through ink-black water searching for food that only appears in brief, unpredictable falls from the surface, and the young fish grow to adulthood in a world with no seasons, no light, no shelter, and no safety. And yet they survive. They thrive. They build families in the deepest, darkest, most crushing environment that any fish has ever called home, and they do it so quietly that humanity only learned about them in a single piece of footage. This is where the wonder and the fear meet. Because watching that fish is watching life do something that feels like a miracle even when you know it is biology. The snailfish shrugs off 800 atmospheres of pressure the way you shrug off the weight of the air, because its body is mostly water, and water cannot be compressed. So the pressure simply passes through it without resistance. Its bones are soft, its flesh is jelly, and it carries no air pockets that could collapse, which means the crushing force of the deep has almost nothing to grab onto. A creature built this way is not living in spite of the pressure. It is living in perfect agreement with the pressure, and that is the elegant, almost impossible trick at the heart of the whole story. But the pressure was never the real wall, and this is the part that makes the discovery so haunting. The real wall is the chemistry, the TMOAO problem. The calculation that says a fish deeper than roughly 8,400 meters would need so much protective chemical in its cells that the chemical itself would start tearing the cells apart. The snailfish filmed at 8,336 meters is swimming just a few hundred meters below that theoretical ceiling, and the scientists who study this say the fish may be right at the very edge of what is chemically possible for a backboned animal. There may be fish just a little deeper, or the ceiling may be real and absolute. But either way, that pale juvenile is living closer to the absolute limit of fish life than any creature we have ever seen. And then there's the other impossible problem, the problem of food, because a fish cannot live in the deepest trench in the ocean if there is nothing to eat. The snailfish survives on what falls from above, a slow drizzle of dead plankton, sinking carcasses, and the endless rain of marine snow, and it hunts the amphipods that gather around any scrap of food. The mackerel bait on the landers was a feast, and the footage shows the snailfish arriving the way a predator arrives when it knows the scavengers have already found the food. Down there, every meal is a gift from the surface, every calorie has fallen through miles of cold, dark water, and the entire food web of the hadal zone hangs on that thin, unpredictable rain from above. The discovery also quietly rewrites what we thought. We knew about how deep life can push, because the snailfish is not the only creature living at the edge of the impossible. A few years before the snailfish footage, the deepest octopus ever filmed was recorded at nearly 7,000 meters in another trench, a pale Dumbo octopus flapping its ear-like. Fins in water that should have been beyond any soft-bodied animal. And amphipods, those tiny shrimp-like scavengers, have been found and filmed even deeper, past 10,000 meters, in the very bottom of the Challenger Deep, nearly 11,000 meters down. The pressure that stops fish does not stop everything, and every rung of that ladder is occupied by something that figured out how to be alive where nothing should be. Stand back and look at the whole picture, and the scale of what we do not know becomes almost unbearable. We have explored the surface of the moon more thoroughly than we have explored the deepest parts of our own ocean, and the hadal zone, the layer of trenches that covers this hidden world, has been studied less than almost any other habitat on Earth. Every expedition that goes down there with a camera comes back with something that was not in the textbooks, and this expedition was no exception, because it did not just find the deepest fish ever filmed. It found fish living at the exact depth where the chemistry said they could not live. And it proved that our models of the deep ocean are still maps drawn in pencil, waiting to be corrected. The strangest part of the story might be what the landers did not find. The team deployed their cameras all the way down to nearly 9,800 meters, deep into the heart of the trench. And at those deepest sites, on the very floor of the abyss, the cameras found no fish at all. The snailfish appeared between roughly 6,800 meters and 8,336 meters, and then, below that, the fish simply stopped, exactly where the chemistry predicted they would stop. That empty water at the bottom of the trench is not a failure. It is confirmation, proof that the wall is real, proof that the snailfish is swimming with its nose pressed against the absolute ceiling of fish life. And it makes the footage even more precious, because evolution has drawn a line in the darkness, and this little fish is standing on it. The scientists who made this discovery have been careful not to overclaim, and that honesty is part of why the find matters so much. They do not say the snailfish is the deepest fish that could ever exist, because the ocean has a way of humbling anyone who makes confident predictions about it. They do not say there's nothing deeper, because the trenches below 8,400 meters are still almost completely unexplored, and there may be surprises waiting in the black that no camera has ever reached. What they say is that this fish was filmed at 8,336 meters, that it was alive and swimming and completely at home, and that the old assumption about where fish life ends has been quietly pushed deeper into the dark. That is enough. That is history. So here is the question that stays with you after the footage fades. If a fish can live at 8,336 meters, just a few hundred meters below the depth where the chemistry of life was supposed to run out of room, then what else is down there? The trench floor waits nearly 10,000 meters below the surface, and the water between the snailfish and that floor is still, for the most part, a total mystery. There may be other fish squeezed into the gap, species that evolved differently and pushed a little further, or there may be nothing, a silent zone where only amphipods and microbes keep the last ember of life burning. Either way, the ocean has given us a gift, a single grainy image of a pale fish that proves life is more stubborn, more adaptable, and more mysterious than our best models ever imagined. The deep ocean keeps its secrets well. It has kept them for 3 billion years, through the rise and fall of every creature that ever lived on land, and it does not give them up easily, only in fragments. Only at the cost of years of patient work, only to people willing to wait in the dark for something to swim into the light. That little snailfish, 11 centimeters of jelly and determination, has become a symbol of everything the ocean still hides from us, because it sat at the edge of the impossible for millions of years before any human being ever knew it was there. Every time a lander goes down, every time a camera reaches a little deeper, the record may move again. And the only honest thing anyone can say about the deepest fish in the ocean is that we have not met the last of them yet. If this story made you feel that strange pull of the deep, the mix of fear and wonder that keeps people staring at the water and wondering what is below, then tell us in the comments what you think lives at the very bottom of the trench. Because your theory is as good as anyone's, and the scientists who study this would tell you the same thing. And if you want to be here for the next ocean mystery, the next record broken in the dark, the next creature that should not exist but does anyway, then subscribe and turn on the notifications. Because this channel is going back down there, and the deep is always willing to show us something new. Until then, keep looking at the ocean and remember what it is hiding Because somewhere down there, 8,336 meters below the surface, in water that has never seen light and never will, a pale fish is still swimming, right at the very edge of everything a backbone can bear, and it is waiting to see what we find next.